Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Moving on, we have our CCNP, our Simple Network Management Protocol. And basically, CCNP was developed to allow administrators to manage the network and manage the nodes that are on the network, because as the network grows, the staff doesn't always grow. So the administrator's ability to manage those devices have to become a little bit more fluid, flexible, and a little easier. So with CCNP, that's how it's done. CCNP is an application layer protocol that does provide message formats for communications between a manager and the agent. The manager is going to be like a workstation. The agents are going to be the end devices. And the big thing is our CCNP systems as a whole have three main elements. The manager, that's going to be the main workstation. Our agents, those will be the managed nodes. And the MIB, the Management Information Base, MIB. The entire purpose of this is so that CCNP will define how the management information will be exchanged between the application, the manager, and the agents. The CCNP manager will pull the agents and query the MIBs for each of those agents using UDP port 161. The agent will send any updates or traps to the CCNP manager on UDP port 162. So CCNP uses UDP ports 161 and 162. So how does this work exactly? The CCNP manager is part of the management system, the NMS. The CCNP manager will collect information from the agents using GET actions. And they can change configurations by using set actions. The agents will forward the information to a manager using traps. And we're going to go through some of this lingo a little bit later. The CCNP agent and MIB will reside on the client device. The MIBs store data about the device, the operational statistics, the available resources, the authentication ability, things of that nature. So what exactly does that mean? One of the biggest use cases that I've used CCNP for is like printer management. I may manage 50 printers throughout my organization. I can set CCNP to alert me on page count, paper count, toner levels. That way, as I start seeing that my devices are getting low on toner, I can get an alert and I can have replacement toner sent a little sooner than normal. That allows me to effectively manage my end devices. And I use printers as the example because realistically in an office setting, when there's a very small IT group or management team, the printer, they're probably one of the biggest things that will be reviewed and managed and reported on the most. If I need to update a router or a switch, yes, CCNP can do that as well. However, the amount of time that I'm going to use CCNP to manage a device like a router or a switch versus the amount of time that CCNP will be reporting on a printer, the printer is going to be used a much more regular basis. So being able to utilize the resource management and the resource tools for the printer is going to be extremely important. So let's look at our agents. They will reside on the managed device and they will collect and store information, and they will store it locally in the MIB. The manager will use the agent access information within that MIB. So we can do things like a GET request or a GET next request. They will retrieve values for very specific variables. Maybe we need to do a bulk. We need to get several pieces of information. We could also do responses. Responses basically reply to GET requests, GET next, and set requests. And again, a set request is something that will be changing a stored value. So GET will retrieve, set will actually put a stored value in place. So what actually happens with these requests? Essentially, the agent will respond to the manager's request as followed. It will get an MIB variable. The agent will perform the function depending on whatever it's supposed to be doing. Then it will set the appropriate variable if that's what was required. So the first one would be obtaining information. The set will be actually setting the variables on the agents. So the agent trap. So a trap are unsolicited messages alerting the management station to a condition or an event on the network. The trap will be directed notifications, reducing the network and agent resources by eliminating the need of some pulling requests if an interface goes down. Instead of the manager station having to pull the device will just send an update. Hey, my interface went down, assuming that's what was configured. There are multiple versions of SNMP. The common ones are version 1, version 2C, and version 3. Version 3 being the newest one. And version 3 uses username and authentication. It provides data protection using hashing algorithms, MD5 and SHA, and it will also encrypt using standard SSS, AES forms of encryption. 2C, it's more of a simple string, no real encryption. It does still have authentication methods, and it does provide for bulk retrieval options, but again, it's not as secure as our version 3. So version 1 and version 2 both use what's called a community string, and that controls the access to the MIB. So essentially, there are two types of ways for this to happen. When the community string is configured, it will have to authenticate access to the object, and then once it authenticates, it has two permissions, read-only and read-write. The read-only basically only allows access to the MIB variables, but don't allow for any modification. When you have the read-write option, this will provide the rewrite access to the object. So to be able to view or set the variables, the user must specify the appropriate community string for the level of access that is needed. For our MIB object IDs, those are normally called an OID, object ID. The OIDs uniquely identify managed objects. These MIB organize the OIDs based off of the appropriate RFC standard. So basically what ends up happening is, let's say we're managing a printer. Well, the printer is going to have multiple object IDs that all of the sub-features of that device. So we can actually start managing certain areas of the printer, for example, based off of the OIDs. And the OIDs are actually built off of a hierarchy, and they're normally shown in a tree-like structure. The MIB tree for any given device will include branches with the appropriate variables. The RFCs will define some common public variables. Most devices will implement these MIB variables in an appropriate way. So here is an example. We could have an OSI, an org, a DoD, an internet, a private, enterprise, Cisco, and then we could have different local variables. Well, you'll notice these numbers are actually the tree-like structures. So here we have an OID belonging to Cisco. They are numbered as followed. iOS, that's given a 1. That feeds into the org, which is the second. I'm going to grab my pen. So here's our first number, our second number, third number, fourth number, fifth number, sixth number, and so forth. And these numbers correspond to our OID spots. And then once it passes 9, it will actually either go variables for local variables, interfaces, or other groups. Here's an example of us being able to see it. We have an SNMP GET request. We have our version. We have our community. We have an address. And we have the appropriate OID number. And again, we're assuming that we know what that OID number is. And that I'm going to explain in 1 second. The return will actually be an integer, and that will be a CPU value. So how do you get the OID numbers? Well, realistically, you're going to have to know the specific device and the settings for that device. They will help you define the appropriate OID information. I can honestly say this has been the most frustrating portion of dealing with SNMP, is building out the OID information, because sometimes these numbers are not as easy to guess or to use or to decipher as they should be. We definitely have a lab covering this as well. Moving on, we have our syslog. First of all, syslog will use UDP port 514. This is going to be sending information across the network, typically to a centrally logged server. If we have devices, we can have those devices forward their logs to the syslog server. A syslog server does provide three main functions. Gather logging information for monitoring and troubleshooting. It gives us the ability to select the type of logging information that we want to be capturing. Also, it gives us the ability to specify the destination of the captured system log messages. Logs can come from the buffer of a device, the command line, the terminal line, or syslog servers. So these are all very common destinations for the log information to end up. The device itself can generate logs from everywhere, from anywhere. But how are we reviewing that log information? How are we reviewing it? If we're on the device could have a log generated for the local device and put it into memory. We could view the local log. If we're on the device via its terminal or through its console connection, we could see the log information there, or we can have, again, dump it to a log server. The important part is understanding the severity of the logs. There are 8 levels, 0 through 7. Normally this is not CCNA material. You don't need to memorize the levels. This is definitely something you have to memorize for CCNP. So each of the logs will have a very specific level. You can have a level 3 log, and that's going to be an error condition. Or maybe you only want to display level 4 and above. Well, you can do that. You can set what log message level are going to be actually sent and where you're going to do them. Our facilities, basically our device can generate logs based off of anything. Interface, the operating system, the protocols. Normally, if we turn on or turn down an interface, throughout our labs we've seen something similar to this. We have a link 3. It is up. The interface port channel has changed to the status up. Notice link 3, it's a level 3. How do we go ahead and configure things? Well, we've already looked at how to set up NPP. We've already looked at essential how to do our syslogs. The problem is our syslogs by default don't have timestamps. So we need to actually be able to set up our timestamps. We do that by issuing a service timestamp log date time from the global configuration. That dictates that we are going to have timestamps on our logs. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.